Hello everyone. Today I'll be explaining you the program 2 of part A, which is implementing a 4-node point-to-point network with the links N0 to N2, N1 to N2 and N2 to N3, and also applying the TCP agent between N0 to N3 and UDP between N1 to N3. Then we'll be applying the applications over TCP and UDP, and also we'll be determining the number of packets sent by TCP and UDP. This is the second program which is already done in the lab. Now before going to that, let us revise about the simulator used, that is Network Simulator NS2. Here the overview of this is, it is a discrete event simulator which works at the packet level, and there are different network protocols which can be used in this, like TCP, Renault, Tahoe, Vegas. All these are the different protocols. This is known as NS2, and it is useful to study the dynamic nature of the communication networks and the simulation of wired as well as wireless network functions, and the protocols can be done. This network simulator 2 provides users with a way of specifying the network protocols and simulating their behavior. The platform used are, we'll be using a Linux platform, and here in this, NS is a simulator which is a network simulator. Then NAM, that is network animator, is used for the visual demonstration of the NS output, and then for pre-processing we'll be writing a TCL script, which is a tool command language, and for the post-analysis we'll be writing a awk code. This is the components. So remember about the TCL script, which will be generated here by its own, then the network animator window, and the post trace analysis is done by using the awk code. So this is the architecture of NS2, and this is the user perspective. That is, from the user perspective, NS2 is an OTCL interpreter that takes OTCL scripts as input and produces a trace file as the output. So we'll see the trace files, its format, all that in the later. Now NS2, you can see here it is a discrete event driven simulation. So you can see here time, as the time proceeds, we'll be seeing it is with respect to the TCP and the UDP protocol, which is at the transport layer. We'll be seeing the movements of the segments. Next is in the TCL script, actually it has first the new files opening and turning on the tracing, then creating the nodes and setting up the links, then configuring the traffic type TCP or UDP, then we'll be setting the time of the traffic generation, then terminate the simulation. These are the steps to be remembered. Next is the procedure. So these are the commands which you have to remember, that is java -jar nsg 2.1.jar, which is to invoke the NSG model. Next, to edit the TCL code, once we choose a folder, we have to write gedit and the file name .tcl, it is the TCL script. Then once we type the code, once we have the edit window, we can make any changes. Now as here in our lab, the TCL script gets generated. So once it is generated, you have to just run it using the code ns_filename.tcl, which is used to execute the TCL code. Then to observe the trace file, it is gedit filename.tr is used. This, once you perform the network simulation, two files are getting created. One is with the .tr and one is with the .nam. So these are said to be the trace file and the nam file, which you can observe in the same folder along with the TCL code file. Next, for the post trace analysis, we have to write the awk program. So it is gedit filename.awk. Then to execute that, it is awk -f filename.awk followed by filename.tr. So from the trace it takes that as the components and it will be given as an input to the awk, and then we'll get the final output. Now let us see with respect to the program. So what you have to do is, once open the terminal window and type the command, that is java -jar nsg2.1.jar. remember this command. So once you type that command, you have to press enter. Once you press enter, you will be moved to the window where you have to choose scenario and the wired scenario. In the wired scenario, now this program is, you have to apply the TCP agent, which is a 4-node point-to-point network. So which should have now N0, just place the cursor here, which you have already done, N0, then N1, then N2 and N3. Once it is done, you have to connect it with the links. So as it is already told, the links are N0 to N2, so connect it with the 9. Next is N1 to N2, N1 to N2 and also N2 to N3. Don't connect it in the reverse. So this is the duplex link. Once this connected, then move on to, or these you can change it in the TCL script when it gets generated. Next, in the agent, here we'll be using two agents. One TCP NOT, which is connected to N0, and one more is here sync, which is connected to N3, and connect that. Next is, you have to connect UDP to N1, then connect null to N3, then connect it using the 9, and also you have to have in the application FTP is connected to TCP, and also CBR, constant bit rate, is connected to UDP. So already you have studied about all these. TCP is transmission control protocol, FTP is file transmission protocol and file transfer protocol, UDP is user datagram protocol, and CBR is constant bit rate. Now once these are done, time you can change later in the TCL script. Go to the parameters here. Here you can change the name. So here in this case you can give the name as, since it is program 2, I can give the name as something like 2 and also I can give the NAM file name as 2. You can give any names, but just to identify this I have done, save it as done. Once it is saved, click on the TCL. When you click on this, the TCL script gets generated. Now this TCL script, we can move here up. You can see that it is, first one is the simulation parameters, which tells about time of the simulation. So it will be 10 milliseconds. Then it is related to the initialization, setting the network simulator, opening the tracing. So this is the name that we had given in the parameter. In case if you are not giving it there, you can give the name here and save it. So it is the trace file name, similarly the NAND file name. These are the 4 nodes that were connected, and also this is related to the links and also the between, also the bandwidth and the delay time, and also the queue limit is specified. Later we'll be changing this. And this is about the NAM position, network animator window. This is about the TCP connections, how the TCPs are connected to which agent, sync is connected to which agent, TCP and sync are connected, packet size is specified, and also here related to UDP. Then is the application definition, where we define the time which we have to change it. Next is the finish procedure, where you will be closing all the files, NAM file as well as the trace file. So here, since it is the program which is where we have 2 agents. In the first program there was only 1 agent. Since here there are 2 agents, we have to type the extra instructions is with respect to the color. Since there are two agents in the NAM window, in case if we give two different colors, we can view it as packets with two different colors. So wherever we define the NAM and the trace file, we have to have those color commands, two commands included, which is done. Also you can give the names to the labels, you can change the shape, all that can be done. And also here the bandwidth, you can change it such a way that the first is higher, then the bandwidths are less in KBs, or else you can keep it the same. And also you can change the Q limit. You can do 2-3 different trials by varying these bandwidth and also the Q limit. Next is you have to specify the time here. If you write 1 to 2, only for that duration of time you can see the packet transmission with respect to TCP and also with respect to the UDP. So once it is done, save it. So choose the folder wherever you want to save and give the name. So once you give the name, save it with respect to .tcl and file name and save it. So it will be saved in your folder. Now go to the terminal window. Now if there is no command prompt, type Ctrl+C and then you can open your folder. So go type cd and the folder name. Once you open the folder name, now you can access the files which are stored inside your folder. So since your program, the program which we had already saved is gedit2.tcl, if we type it, it gets opened. So if it is not getting open, so it will be there here. So this is the program. So once you have this program, I have typed these extra commands here now. Color is typed, color 1 is given as blue, 2 is red. These are the two extra commands which I have typed, and also I have made changes here, 800 KB, 700 and 600, and also I have given that one color by using TCP.set class _1. So that one color blue is applied to the TCP packet, and the 2 is red is applied to the UDP packet, and these are the time. So 1 to 4 I have made to run the TCP packets in the NAM window, 2 to 5 it is UDP packets. So once it is done, save the program and then go to the terminal window. So once the program is ready, now we have to execute it. So use the command ns and the program, that is 2.tcl. Once you do ns, if there are errors, it will be displayed. Just check it the first error and then try to correct. Once when you do the ns, you will have two files which gets created. One is said to be the trace file, another is the NAM file. If you go to your folder, you can see here along with the TCL code, earlier it was only TCL code, you will have your NAM file as well as the trace file. So the 2.tr is said to be the trace file which you can open it. This is said to be the trace file, and also the extra file that gets generated will be the NAM file. This is NAM file. We'll see the format of that later. So once it is done, you can see that you can minimize this, which you can access it later. So go to the terminal window. Already ns was done, so you will have this window which gets open. So this is said to be the NAM window. So in this NAM window, when you run it, you can see the packets flowing. So since I have given the time here, you can see it starts from 0 to n. So when it reaches 1, I have given 1 to 2. These are the blue color TCP packets, and also you can see the UDP packets. You can find out the difference here. TCP packets are the connection oriented protocol which has the acknowledgements coming back here. You can see here acknowledgements coming back. But in the case of a UDP, which is a connectionless protocol, there are no acknowledgements coming back. and also you can see the dropping of the packets. This is said to be because of the congestion. Next is, once it is done, you can close this window. Just run it for full time and then you can close the window. So once you have closed it, then next is you have to have, if you want the trace file, you can open it by using gedit 2.tr. Similarly, the NAM file also you can observe. I'll go to it later. Then we have to type gedit 2.awk. I have already typed the program. It is the awk program for the post analysis. Click enter. Once when you click enter, you can see the program. This is a program now to calculate the number of packets sent for TCP as well as UDP. So here it has a format. First is begin, and then you define the TCP count and the UDP count as 0. This is first initialization. Then in the body part, since in the trace file packet is of $5, so there are different fields which I'll show you to you later. So if the packet is CDR, then we'll count the variable for the UDP. If the packet is TCP, you count the variable for TCP. Then the third part is N, where you print it. Whatever you write it within the N printed, this gets printed on the terminal window. So once you type this, save it, go to the terminal window once again and type the code awk-f, then write the file name of the awk code followed by the file name of the trace file. So you will get the number of packets sent, TCP as well as the UDP count. Now let us see those trace and the NAM file. Before that, I have already told about the program. This is the program that we are doing it now. I have already told about the trace file format in the lab. So this is a trace file format with the $1 is even, 2 is time, 3 is from node, 4 is to node. Then we have packet type, packet size, flag. So remember this. Now with respect to the packet, we have packet type. It is 1, 2, 3, 4, 5. So $5 is the packet type. So we have to initialize that. That is what is done here. So in the awk code, it is packet is specified with $5. Then if you write that PKP, which is packet, CBR, it tells that it is the UDP packet. If you write packet as TCP, it tells that it is a TCP packet. So once after that trace file, let us see that trace file. It is with the name 2.tr. So here 2.tr, you can reload this. So here you can see the first field. So the first field that we have is the event. So event can be of the type R or it can be D. So receive, drop, enter, plus, minus. All that are the first event. Then we can see the time. Then it is with respect to the from node and the to node. Then we have the packet type. Then it is the packet length and also the other fields. So remember this. So this is about the second program that we have done it in the lab. So the conclusion is that you can do it for 2-3 different values, and what we can learn here is that by changing the bandwidth, we can change the bandwidth in that TCL board wherever you have a link specified. These values 800, 700, 600, you can change it to different values because we want to see the packet sent, how many packets are dropped, how many packets are received. All that can be found out, which is done in the lab. So just by changing the awk code here, you can, if the event is specified $1 and if event is plus, you can find out how many are entered the queue. If the event is R, how many are received. Also you can see if the event is with respect to the program, if the event is B, how many are dropped. All that can be found out. So this is about the program, and that about the second program. And also one more thing here is that once we have got this is the opcode here, by changing the bandwidth or by changing the queue size, we can see the changing the bandwidth due to the change in the queue size. We can observe for TCP as well as UDP. So thus here the point-to-point network performance can be verified and the number of packets sent by TCP UDP can be noted down. This is about the second program. So remember the trace format, remember the TCL script, remember the opcode, and also remember the network diagram. As it is told in the question, you have to have the network diagram drawn in the same way, and it is 0 to 2, 1 to 2, 2 to 3. These are the links. And also remember, since here there are two agents, TCP and UDP, we have to have different colors we need to give so that we can see it in the NAM window in a colorful way, two different colors. So since we are giving these colors, we have to add it to wherever there is TCP agent definition, we have to set class 1. Wherever there is UDP, we have to set class 2, so that those gets applied with those blue and red color. And also we have to give here, change the timings, otherwise by default it will be 1 to 2, it will run only from 1 till 2. And the opcode, by having the fields defined, remember the fields, we can change this code, but remember to have a begin, then the body part, then the end part. If you write printf within the end, it gets printed on the terminal window. And with respect to the terminal window, whenever you are starting with the program, type java -jar msg 2.1.jar and select wired scenario. And also once you have saved your program in the file, to access that before using any other command, further command, maybe gedit, ms, any command, you have to have your folder open by writing cd jovita or whichever your file name is, and then you have to open your file names, that is by using gedit filename.tcl or gedit filename.tr. You can use any file name by using gedit. And also here having this NAM window here you can with rest by changing the link in the TCL code, that is here you can go to the folder and open it, or you can open it by using gedit onto the terminal window by wearing this these values here, which is 100 MB now. And also Q limit here, you can get different values of packets sent. And also by changing in the opcode here the fields like event, you can calculate the packets drop, receipt. This is about the program 2. Thank you.